Hello there, and welcome to the Peaceful Sleep Channel. I'm so glad you found your way here, to this quiet space. Maybe you've had a long day, or perhaps you're the kind of person who likes to fall asleep to thoughts of nature's grandeur, of the ancient forces that have quietly shaped our world. Whatever the reason, tonight's journey is for you. There is nothing you need to do now. Just rest. Let your breathing slow. Let the thoughts in your mind soften, and allow your body to grow light, as if gravity itself has loosened its hold. Because tonight, we won't be drifting among the stars. We will be journeying deeper, into the very planet we call home. We will listen to its heartbeat, a powerful, slow rhythm made manifest in mountains that breathe fire and stone. Tonight, we will explore the most relaxing facts about volcanoes. You may be surprised to find that behind their fiery reputation is a story of creation, of patience, and of a deep geological beauty. We will not speak of destruction, but of rebirth, not of chaos, but of a profound order. A dance of rock and fire that has been unfolding for billions of years. And just before we begin, if these peaceful explorations help you unwind, or give you a quiet way to end your day, consider gently tapping the like button and subscribing. It helps other sleepy souls find their way here. 2. Now, let's begin. Our story of volcanoes does not begin on the surface, with towering peaks or glowing rivers of lava. No, our story begins somewhere much deeper, a place of quiet and almost unimaginable stillness. It begins in the heart of the world. Imagine yourself drifting downward, sinking through the Earth's crust, past layers of sediment that hold the memory of millions of years. You move through cool, solid rock, and then the space around you begins to grow warm, the pressure builds, and the silence seems to grow thicker, heavier. You are approaching the planet's core, a place where no light can reach, and no sound can escape. The Earth's core is not a roaring furnace. Picture it instead as a silent sun, a solid sphere of iron and nickel, hotter than the surface of our actual sun. It glows, not with light we can see, but with a primal energy. This heat does not come from burning, but from the memory of the planet's formation over 4 billion years ago, and from the slow, almost eternal decay of radioactive elements. Each decaying atom of uranium or thorium is a whisper of time, a tiny beat that helps keep the heart of the Earth warm. It is a cosmic ember, wrapped in thousands of miles of rock, quietly radiating its warmth across the ages. Its existence is a steady, s'il présent, a vast yet gentle source of power that underlies every motion on this planet. The heat from this sphere of metal does not erupt, it seeps, gently and relentlessly, into the rock that surrounds it. Outside this solid heart is an ocean of liquid metal. The outer core. Here, molten iron and nickel swirl in slow, endless currents, their movement, slower than the growth of a tree, generates the Earth's magnetic field, the invisible shield that protects us from the solar wind. Think of it, an ocean of liquid metal, churning in eternal darkness, weaving a protective shell for all life on the surface. A cocoon of energy spun from currents too slow to perceive. This is where the planet's power begins to stir. Not in a fury, but in a waltz of gravity and heat that has lasted for billions of years. Every swirl in this metallic ocean is a note in the symphony of geology, a movement that will shape continents and raise mountains millions of years from now. Surrounding the core is the Earth's mantle. This is a strange world, not quite solid, not quite liquid. It is a thick, hot, and dense layer of rock that flows and deforms under immense pressure. But do not imagine a rushing river. The flow here is impossibly slow. The rock of the mantle moves at a rate of only a few centimeters per year. Slower than your fingernails grow. It is a glacier of rock, a motion almost frozen in time. Over millions of years, these slow convection currents carry heat from the core up toward the surface. Like water gently rolling in a pot set on the lowest possible flame, this process happens in absolute silence, under a pressure that would crush anything we know. It is the quiet engine of the planet. A vast, tireless machine where rock behaves like thick honey, and time is measured in geological epochs. Every small stir in the mantle is a seed of change for the surface, a quiet preparation for the birth of a volcano. It is here, in the upper mantle, where the pressure eases just slightly and the temperature remains extreme, that the magic of transformation begins. Rock, under these perfect conditions, can no longer hold its solid form. It does not melt suddenly. Instead, it begins to sweat, to soften. The minerals with the lowest melting points start to liquefy, like tiny beads of dew forming on a cool leaf. These drops of molten rock, called magma, are lighter than the surrounding rock. They slowly, gently, percolate through cracks and fissures, gathering together, forming silent reservoirs of magma, luminous pockets of liquid trapped deep within the Earth's crust. These magma chambers are the waiting rooms of volcanoes. They can sit there for thousands, even millions of years, like hibernating creatures. Inside, the magma gently swirls, crystals forming and remelting. It is a world of patience. The magma is in no hurry. It waits. It gathers energy, dissolves gases from the surrounding rock, and slowly builds pressure against the crust above. This is not a violent process. It is like the slow breath of a sleeping giant, each breath taking millennia. Each magma chamber is a second heart, beating impossibly slowly beneath the surface, nurturing the energy for an event in the distant future, when the pressure has built just enough, or when a new fracture opens in the crust. The magma begins its journey upward. This is not a violent assault. It is a silent migration. The magma weaves its way through the weakest points in the rock, following existing cracks, sometimes melting its own path. It might move only a few meters in a year. The journey from magma chamber to surface can take centuries. Along the way, it might pause, forming smaller chambers, resting for years before continuing. It is like a subterranean river of liquid light, finding its way through a dark labyrinth of stone. Its progress is marked only by the faintest tremors, seismic whispers that only the most sensitive instruments could ever hear. It is the deep hum of the planet, the rustle of rock shifting to make way for the slow rise of liquid fire. And so, before there is any mountain, before there is any smoke or lava, there is this long and quiet journey, a journey that begins with the leftover heat of creation, is fed by the decay of atoms in the core, is shaped by the glacial flows of the mantle, and is carried out by the patient ascent of magma through the dark crust. The volcano is not an event. It is the culmination of a process that is ancient, deep, and profoundly peaceful. It is the moment when the heart of the earth, after millions of years of waiting, finally reaches for the sky. Let your mind drift with this slow current of molten rock. Feel the deep warmth of the Earth's core, not as a scorching heat, but as a steady, enduring embrace. Imagine the patience of the magma, waiting in the darkness through the ages. Before beginning its long journey, there is no hurry. Everything moves in geological time, a rhythm measured by the breath of epochs. And in this deep stillness, you can begin to feel a sense of peace, the peace of a planet that is alive, breathing, and quietly creating. From the deep, quiet chambers where magma waits, our journey now rises to the surface. But the first volcanoes we will meet are not the jagged, explosive peaks of legend. They are something far gentler. They are the silent architects of our world, the shield volcanoes. To understand them is to understand patience itself, written in stone across entire landscapes. Picture yourself now, not in a place of fire and danger, but floating in the warm, quiet air above the Pacific Ocean. Below you, the island of Hawaii rests in the deep blue water, a green jewel fringed with black sand. This island, and the entire chain it belongs to, was not built by collision or upheaval. It was breathed into existence, layer by patient layer, by the soft and steady work of shield volcanoes. These are the largest volcanoes on Earth, yet their presence is not one of threat, but of serene grandeur. Their slopes are not steep and menacing, but gentle and broad, rising from the sea with a slope so gradual you could walk for miles without feeling you are climbing a mountain at all. They are named for their shape, the broad, rounded shield of a sleeping giant, laid upon the ocean floor. The secret to their gentle nature lies in the magma that feeds them. The magma here is different from the thick, sticky magma that fuels explosive eruptions elsewhere. This magma is fluid, runny, and low in silica, the mineral that makes other lavas thick, like paste. Imagine warm honey instead of cold molasses. Because it is so fluid, gases can escape from it easily, not building up to a violent explosion, but releasing in a steady, quiet sigh. The eruptions here are rarely a cataclysm. They are an offering. Let your mind drift to the heart of one of these mountains. Mauna Loa Orkilaoe. Deep below, a plume of hot rock from the mantle, a steady pulse from the Earth's heart, provides a constant source of heat. The rock melts, and the liquid magma rises, gathering in chambers just beneath the surface. It waits, not with tension, but with a quiet readiness. When the time comes, it does not blast its way out. It wells up. It overflows. Often, the eruption begins not at the summit, but along the volcano's flanks, through long cracks in the earth called fissures. Imagine a line of light appearing on the dark mountain slope at dusk. It is not a violent crack, but a gentle parting, as if the land itself is opening a curtain. From this fissure, lava emerges, not in a torrent, but in a glowing curtain of fire. Fountains of molten rock may dance into the air, sometimes hundreds of feet high, but they are surprisingly quiet. A soft roar like a distant waterfall. They are not explosions of debris, but graceful arcs of liquid light, falling back to earth to feed the flows that will build the land. And the flows themselves are rivers of creation. Watch as a stream of this glowing liquid rock leaves the fissure. It moves with a slow, inexorable grace. The surface may cool into a dark, silvery skin, wrinkling and folding like silk as the molten river flows beneath it. This is the lava known as pahuho, a Hawaiian word that captures its smooth, rope-like texture. It advances not with speed, but with a quiet, unstoppable persistence. It may creep forward for weeks, even months, covering the old land in a new layer of black stone. It is not an act of destruction. It is an act of resurfacing. The lava flows around obstacles, feels depression, and finds the path of least resistance, sculpting the world as it moves. The air grows warm around it, shimmering with heat, and the night glows with its soft, orange light. It is the Earth's own blood, warm and alive, flowing out to heal and build. Over thousands of years, these gentle flows build upon one another. Each eruption adds a new, thin layer to the mountain's flank. It is a process of infinite patience. A single flow might add only a few feet of height, but over 1,000,000 years, these layers accumulate to create mountains that are, when measured from their base on the ocean floor, the tallest in the world. Mauna Kea, though its peak is only 14,000 feet above sea level, rises over 33,000 feet from the seabed. A colossal structure built from nothing more than these quiet, patient overflows. These volcanoes are living proof that the grandest creations in nature are often not the product of a single, violent event, but of countless small, gentle acts repeated over an immense span of time. Where this new land meets the sea, another kind of quiet magic occurs. As the glowing river of lava, over 1,000 degrees Celsius, touches the cool ocean water, you might expect a violent explosion, but often, the meeting is a gentle hiss, a great cloud of steam rising into the sky like a soft exhalation. The lava cools rapidly, shattering into black sand and forming new coastlines. The island grows, foot by foot, acre by acre. It is the only place on Earth where land is being created so visibly, so steadily. You can stand on a cliff of old, weathered lava and watch the birth of new Earth unfolding below you. The steam that rises carries the scent of sulfur and salt, the smell of creation itself. It is the planet's own alchemy, turning fire into stone, and stone into land. And life is never far behind. Within years, sometimes even months, the first seeds, carried by wind or birds, find purchase in the cracks of the new lava. Ferns unfurl their delicate fronds against the black rock. Small shrubs begin to grow, their roots seeking out pockets of moisture. The process is slow, but it is a testament to life's tenacity. The land that the volcano offers is stark and new, but it is also rich in minerals. It is a blank canvas, and life, in its quiet, persistent way, begins to paint it green. So, as you rest, let your thoughts settle on these gentle giants. Do not picture them as mountains of fire, but as architects of stone. Picture the slow, steady pulse of magma rising from deep within the earth. Picture the graceful curtains of fire, the quiet rivers of glowing rock, and the patient building of land, layer upon layer. These volcanoes are not symbols of chaos. They are symbols of growth. They are the calm, creative force of the planet made visible. A reminder that even from the hottest fire, the most serene and lasting beauty can be born. The shield volcano does not shout its power. It simply builds, quietly and endlessly, offering new ground for the world to grow upon. Now, let us leave the gentle, sprawling slopes of the shield volcanoes and drift across the world to a different kind of mountain. Let your mind travel to the shores of Japan, where the perfect, snow-capped cone of Mount Fuji rises from the landscape. or to the Cascade Range of North America, where Mount Rainier and Mount Hood stand like silent, watchful sentinels. These are the stratovolcanoes, the iconic, beautiful, and complex mountains that have captured the human imagination for millennia. If shield volcanoes are the patient builders, then stratovolcanoes are the master sculptors, crafting their forms with a different kind of artistry, one of layering, patience, and immense, quiet power. Unlike the fluid, honey-like lava of Hawaii, the magma that feeds these volcanoes is thicker, stickier, and rich in silica. Imagine not honey, but thick, cool peanut butter. Because it is so viscous, gases cannot escape easily. They remain trapped within the magma, like bubbles in a thick stew, building pressure slowly over centuries. This stored energy is what gives these volcanoes their potential for more dramatic expression. But their story is not one of constant eruption. Their story is one of long, deep slumber. For hunas, even thousands of years, a stratovolcano can sleep. Its slopes covered in forests, its peak capped with snow, giving no outward sign of the slow chemistry unfolding deep within. Picture yourself on the quiet, forested flank of one of these sleeping giants. The air is cool and still. Birds sing in the canopy. A gentle stream, fed by melting snow from the summit, whispers over moss-covered stones. The ground beneath your feet feels solid, ancient, and permanent. It is hard to imagine that this entire mountain was built by fire, but it was. Its entire existence is a monument to a cycle of eruption and repose, a rhythm of geology that moves on a time scale far beyond human perception. The creation of a stratovolcano is a work of careful layering. Imagine a potter at a wheel, slowly adding layers of clay to build a vessel. The volcano does the same, but its materials are fire and ash, and its timeline is measured in epochs. An eruption occurs, perhaps not a colossal explosion, but a series of smaller events. A flow of thick, slow-moving lava oozes down a flank, not traveling far before it cools and hardens into a dense layer of rock. Then, perhaps, the pressure shifts, and an eruption of ash follows. A great plume rises into the sky, and the fine, gray particles drift down, blanketing the mountain in a soft, new coat. This ash, over time, compacts into a rock called tuff. Then, the volcano falls silent again, for a century, or 5, or 1,000 years. It rests. Snow falls and melts. Glaciers may form, carving gentle valleys into its slopes. Forests grow, their roots binding the layers of ash and lava together. The mountain seems to have returned to the earth, a simple peak of rock and ice. But deep below, the magma chamber is slowly, silently refilling. Gases are once again dissolving into the molten rock, and the pressure is imperceptibly building. When the next eruption comes, it adds another layer, another flow of lava, another blanket of ash, and so it goes. Over hundreds of thousands of years, lava, ash, lava, ash. Each layer contributes to the mountain's shape, building it higher and steeper. The hardened lava flows act as a strong internal skeleton, while the softer ash layers fill in the form, creating the beautiful, symmetrical cone that we find so awe-inspiring. Mount Fuji's perfect symmetry is not an accident of nature. It is the result of countless individual eruptive events, each one contributing its small part to the final, magnificent form. It is a masterpiece of geological patience. Even the more powerful eruptions, when viewed through this long lens, and become part of a creative process. When a stratovolcano erupts more forcefully, it can send a column of ash and gas miles into the stratosphere. From the ground, it may seem chaotic, but from a distance, it is an expression of the planet's inner energy, a great plume of steam and earth reaching for the sky. The ash that falls is not waste. As we will explore later, it is a gift of fertility. The pyroclastic flows, those fast-moving clouds of hot gas and ash, are not just destructive, they are sculptors, carving new channels and valleys into the mountain's face, reshaping its profile for the next era of slumber. And in the aftermath, there is always quiet. After the eruption ends, a profound stillness settles over the landscape. The newly laid ash is silent and gray. The hardened lava is a field of black, jagged stone. But this stillness is not the stillness of death. It is the stillness of a new beginning, the stillness of a canvas waiting for the first touch of paint. And life, as it always does, returns. The wind brings the first spores of lichens and mosses, which begin the slow, patient work of turning rock into soil. The first hardy flowers, like fireweed, push up through the ash. Their bright colors, a stark and beautiful contrast against the gray. Birds fly over, dropping seeds, and slowly, patiently, the forest begins to reclaim the slopes. To stand on a stratovolcano is to stand on a living history book. Each layer of rock beneath your feet is a chapter in that history. A story of a fiery eruption followed by a long, quiet peace. You are walking on the cooled embers of ancient fires, now covered by soft earth and whispering trees. The mountain itself is a testament to the balance between energy and rest, between creation and dormancy. It teaches us that even the most powerful forces in nature operate on a rhythm of action and stillness. So as you drift deeper into rest, let your mind hold the image of one of these majestic peaks. See it not as a source of danger, but as a work of art, sculpted over eons. Feel the deep, slow peace of its long slumbers. Imagine the gentle fall of ash, like a soft gray snow, and the slow, crawling advance of a thick lava flow. See the mountain breathing, not in minutes or hours, but in centuries. Its existence is a long, slow exhalation of the earth, a reach for the sky, built from fire, shaped by ice, and finally, embraced by life. These mountains are not just geological formations. They are quiet reminders of the beauty that can be built from a cycle of fire and peace. We have felt the deep, quiet warmth of the Earth's core and witnessed the patient artistry of volcanoes building themselves on the surface. But what is the unseen force that dictates where these mountains of fire can rise? The answer lies in a dance so slow and vast, it makes the growth of a mountain seem swift. It is the slow breath of the earth itself, made manifest in the movement of tectonic plates. Imagine the surface of our planet not as a solid, unbroken shell, but as a mosaic of enormous, rigid puzzle pieces. These pieces, the tectonic plates, are miles thick and can be as large as entire continents. They are not fixed in place. Instead, they float upon the softer, hotter rock of the mantle beneath, a layer known as the asthenosphere. Picture them as colossal rafts, drifting on a slow, deep, and viscous ocean of stone. Their movement is imperceptible to us, slower than the growth of your hair. But over millions of years, it reshapes the world. It carries continents across the globe, opens vast oceans, and raises mountain ranges. This movement is the heartbeat of our planet's geology, and it is the primary reason volcanoes exist where they do. Most of the world's volcanoes are not scattered randomly. They are found in long, elegant lines that trace the boundaries where these great plates meet. It is at these edges, these seams of the world, that the deep energy of the Earth finds its way to the surface. Let us drift now to one of these boundaries, a place where two plates are gently moving apart. This is a divergent boundary. You can find them on the floor of our deepest oceans, like the Mid-Atlantic Ridge. Here, the Earth's crust is being slowly, quietly stretched thin as the plates pull away from each other. Magma from the mantle rises to fill the gap. It is not a violent process. It is a constant, gentle welling up, like a spring of molten rock. As this magma meets the cold ocean water, it solidifies, creating new oceanic crust. This process, happening in the silent, crushing darkness of the deep sea, is continuously creating new seafloor, widening the ocean basin by a few inches every year. Volcanoes are born here, long undersea mountain chains that form the longest mountain range on Earth, a hidden world of quiet, continuous creation. Now, let your mind drift to a different kind of boundary, where two plates are moving toward each other, a convergent boundary. This is where some of the planet's most powerful and beautiful dramas unfold. When a dense oceanic plate meets a lighter continental plate, something remarkable happens. The oceanic plate, heavier and older, gracefully bows and begins to sink back into the mantle. This process is called subduction. It is not a crash. It is a slow, élégant descent, a return to the depths from which it came. As this plate sinks, it carries with it water trapped in its minerals, deep within the mantle. The heat and pressure release this water. The water then rises into the hot, dry mantle rock above it, and it works like a magical key. It lowers the melting point of the rock, causing it to liquefy and form magma. It is here, in this process of subduction, that the magma for the great stratovolcanoes is born. This new magma, buoyant and full of dissolved gases, begins its slow, patient journey upward, eventually feeding the volcanoes that stand on the continent above. This is why we see long, curving chains of volcanoes along the coasts of continents, like the Andes in South America or the Cascades in North America. Each mountain is a surface expression of this deep, slow recycling process, the sinking of an old world giving birth to a new one. It is a cycle of profound balance. The creation of new crust at divergent boundaries is balanced by the return of old crust at subduction zones. The Earth is constantly renewing its own skin. And this brings us to the Ring of Fire. The name sounds intense, dramatic, but let us reimagine it not as a ring of danger, but as a necklace of creation. It is a vast, horseshoe-shaped path that traces the edges of the Pacific Plate, stretching from New Zealand, up through Southeast Asia and Japan, across to Alaska, and down the west coast of the Americas. Along this 25,000-mile-long path, the majority of the world's volcanoes and earthquakes occur. It is the most geologically active region on the planet, but it is active because it is where the great dance of the plates is most vivid. Here, The massive Pacific plate is subducting beneath several other plates. Its slow descent into the mantle is what fuels the hundreds of volcanoes that dot this ring. Each volcano in the Ring of Fire is a bead on this planetary necklace, a testament to the creative power of subduction. They are not random outbreaks of fire. They are connected, part of a single, vast geological system that encircles the world's largest ocean. So, as you rest, feel the slow, immense movement of the earth beneath you. Feel the continents drifting like sleeping giants on a sea of soft rock. Feel the gentle stretching of the ocean floor and the graceful descent of old plates returning to the deep. This is the breath of the earth, a slow, rhythmic inhale and exhale of rock and fire that takes place over millions of years. Volcanoes are not anomalies. They are the places where we can feel that breath. They are the portals where the inner life of our planet becomes visible, reminding us that the ground we stand on is not static, but alive and in constant, quiet motion. The Ring of Fire is not a warning. It is a celebration of the planet's vitality, a luminous circle of creation drawn by the slow, silent dance of the continents. When we imagine a volcanic eruption, our minds often conjure images of glowing lava, but many volcanoes express their power in a form that is quieter, subtler, and ultimately, far more life-giving volcanic ash. Let us now drift into the heart of a great plume of ash, not as a cloud of destruction, but as a soft, gray blanket carrying the promise of renewal. An eruption begins, and a column of gas and pulverized rock rises miles into the sky. It is not smoke. It is a dense, billowing cloud of tiny fragments. Rock that was once deep within the earth has been superheated, shattered by the rapid expansion of gas, and flung into the atmosphere. These fragments, some as coarse as sand, others finer than flour, are what we call volcanic ash. As the plume rises, it cools and spreads. Carried by the high-altitude winds, the larger particles fall back to Earth quickly, close to the volcano. But the finest dust can travel for thousands of miles, circling the entire globe. Imagine this cloud, not as a menacing shadow, but as a great, gray river flowing through the sky. It is silent. Up in the stratosphere, there is no sound, only the slow, graceful drift of these tiny particles. They are so fine that they can remain suspended for days, even weeks, painting the sunsets of distant lands in spectacular shades of orange and pink. The brilliant sunsets that followed the 1883 eruption of Krakatoa were seen around the world, a beautiful and gentle reminder of a powerful event happening half a world away. These particles of ash are like stardust born from the earth, temporarily rejoining the sky. Eventually, gravity and weather bring the ash back down. It settles over the landscape like a soft, gray snow. It covers everything: leaves, branches, fields, and rooftops in a uniform layer. The world becomes hushed, muffled by this new blanket. The immediate effect can be disruptive, but this is a short-term story. The long-term story is one of astonishing fertility. Volcanic ash is not just inert dust. It is packed with essential minerals that have been locked away deep within the earth. It contains potassium, phosphorus, calcium, and a host of micronutrients that plants need to thrive. When this ash settles on the ground, it is like a massive, slow-release dose of fertilizer for the entire ecosystem. Rain slowly washes the minerals into the soil, replenishing what has been lost over centuries of growth and erosion. This is why the lands around volcanoes are some of the most fertile and agriculturally productive places on Earth. The slopes of Mount Vesuvius in Italy have been home to vineyards and orchards for thousands of years. The soil enriched by countless past eruptions. The volcanic soils of Indonesia and the Philippines support dense populations. Their terraced rice paddies carved into the flanks of sleeping giants. The farmers who live there understand the volcano's dual nature. They respect its power, but they also depend on its gifts. The ash is not a curse. It is a promise of a rich harvest. Think of the process as the earth renewing its own soil. Over long periods, soil can become depleted, its nutrients washed away. A volcanic eruption is one of nature's ways of bringing fresh material from the deep earth back to the surface. It is a geological reset. The layer of ash may initially smother some plant life, but in doing so, it creates a perfectly prepared seedbed for what is to come. And the return of life is a quiet and beautiful thing to behold. After the ash has settled, the first rains come, turning the gray dust into a dark Richmut, and then the first signs of green appear, hardy pioneer plants. Their seeds, having survived the eruption, push their way through the new layer of soil. Their roots find a medium that is light, airy, and full of nourishment. They grow with a vigor they might not have found in the old, tired soil. The ash also changes the landscape in other subtle ways. It can dam rivers, creating new lakes. It fills valleys, creating flat, fertile plains. The very texture of the land is softened, its sharp edges rounded by this gentle deposition. It is a slow and quiet form of sculpting, done not with force, but with a delicate, widespread fall of dust. Even in the oceans, volcanic ash plays a life-giving role. When ash from a coastal or island volcano falls into the sea, the iron and other minerals within it can trigger vast blooms of phytoplankton. These microscopic organisms are the foundation of the marine food web. The ash cloud that seems to darken the sky above the water is, in fact, delivering a feast to the invisible life below. This bloom of life, in turn, absorbs carbon dioxide from the atmosphere, playing a small but significant role in the planet's climate balance. So, as you settle into a deeper state of relaxation, change your image of volcanic ash. See it not as a choking cloud, but as a nourishing one. Picture the silent, graceful drift of fine particles through the high atmosphere. Imagine the soft, quiet settling of this gray blanket over the land, and feel the deep, slow process of renewal it brings. The ash is the earth turning itself inside out, bringing its hidden wealth to the surface. It is a promise that even after the most powerful event, a time of quiet growth and abundance will follow. It is the gentle, dusty breath of the volcano, a gift to the future. Our journey into the quiet world of volcanoes has shown us how they build land and enrich the soil. But their most profound act of creation may be the very air we breathe. Long before there was life, before there were oceans, the first volcanoes spoke, and their language was gas. Let us now listen to that ancient whisper, the slow exhalation from the deep earth that created our world's first atmosphere. Picture the earth in its infancy. Over 4 billion years ago, it was a world of rock and fire. Its surface, a chaotic landscape of cooling magma and constant meteorite impacts. There was no blue sky, no white clouds, no breathable air, the primordial atmosphere, if it existed at all, was a thin, tenuous veil of hydrogen and helium, the leftover gases from the solar system's formation. But this thin cloak would not last. The solar wind, a constant stream of particles from the young sun, stripped it away, leaving the planet naked and airless. But the Earth was not silent. Deep within, its internal heat was churning, and magma was forming. As this molten rock rose toward the surface, the immense pressure that held gases dissolved within it began to decrease. Just as opening a bottle of soda releases the carbonation, the rising magma began to release its trapped volatiles. When the first volcanoes erupted, they spewed not only lava and ash, but also vast clouds of gas. This process is called outgassing, and it was the Earth's first, and most important, act of creation. Imagine standing on that ancient, barren landscape. A volcano erupts, not with a deafening roar, but with a great, sustained hiss. A column of steam and gas rises into the thin, black sky. This is the planet's first breath, and this breath contained the building blocks of our world. The most abundant gas released was water vapor, H2O, trillions of tons of it, locked away inside the minerals of the Earth's mantle, were now being carried to the surface and released into the sky. This was not the gentle steam of a kettle. It was a planetary-scale exhalation, an outpouring of moisture that would continue for millions of years. As this water vapor rose, it began to form thick, dense clouds that shrouded the entire planet. The young Earth was a world perpetually overcast, its surface hidden beneath a global blanket of steam. For millennia, the rain fell. It was not a gentle shower, but a relentless, planet-wide deluge that lasted for an unimaginable time. This great rain, sourced from the breath of volcanoes, slowly filled the basins and craters of the barren landscape. It was in this way that the first oceans were born. The vast blue heart of our planet, the cradle of all life, was a gift from the fiery mountains. Every drop of water in our oceans, every cloud in our sky, every sip of water you have ever taken, contains molecules that once journeyed from the deep mantle to the surface in the heart of a volcano. But water vapor was not the only gift. Volcanoes also breathed out carbon dioxide, CO2. In the early atmosphere, CO2 was far more abundant than it is today. It created a powerful greenhouse effect, trapping heat from the sun and keeping the young planet warm enough for liquid water to exist. Without this volcanic blanket of CO2, the Earth might have frozen into a permanent ice ball. The volcanoes acted as the planet's first thermostat, regulating its temperature and creating an environment where life could eventually take hold. They also released nitrogen N2, the very gas that makes up nearly 80% of the air we breathe today. Nitrogen is relatively inert, and over billions of years, as other gases were processed by life or locked away in rock, it slowly accumulated to become the dominant component of our atmosphere. The stable, gentle pressure of the air around you right now has its origins in those ancient, fiery exhalations. And there were other gases too, in smaller amounts, sulfur compound, which would have given the early air a sharp, pungent smell, traces of methane and ammonia. These gases created a chemical soup in the atmosphere, energized by lightning and ultraviolet radiation from the sun. In this primordial cauldron, scientists believe the first complex organic molecules may have formed the very precursors to life. The breath of volcanoes didn't just create the stage for life, it provided the raw ingredients for the actors. Even today, volcanoes continue this quiet, vital work. They are still breathing. Every day, volcanoes around the world release water vapor, carbon dioxide, and other gases into the atmosphere. This process is a crucial part of the Earth's long-term carbon cycle. Volcanoes act as a natural release valve, returning carbon that has been locked away in the mantle back to the surface. This slow, steady input helps to balance the carbon that is removed from the atmosphere by weathering and biological processes. It is a cycle of planetary breathing, with volcanoes representing the slow, deep exhalation. So, as you lie here, breathing in and out, to feel the connection between your own breath and the ancient breath of the earth. The air that fills your lungs is a legacy of fire. It was forged in the heart of the planet and delivered to the surface by the slow, patient work of volcanoes. They did not just build the ground beneath our feet. They wove the invisible ocean of air that surrounds us. They gave us our oceans and wrapped the world in a warm blanket, creating the gentle, stable home that allowed life to flourish. The volcano's whisper from the deep was the first word in the long story of life on Earth. Let us now return to the edge of the world, to the place where the two great forces of our planet meet in a creative, embrace the fire of the earth and the water of the ocean. It is here, in this dynamic space, that some of the most beautiful and dramatic acts of creation unfold. It is here that new land is born from the sea. Imagine yourself floating above a vast expanse of deep blue ocean. Far from any continent, the water is clear, and the only sound is the gentle sigh of the wind across the waves. Then, from the abyssal depths, something begins to stir. A volcano on the ocean floor, a seamount, has been growing quietly for millennia, layer by layer, eruption by eruption. It has been building itself upward from the dark. For thousands of years, its existence has been a secret, hidden beneath miles of water. But today, its journey reaches a milestone. Its peak, after a long and patient climb, finally breaks the surface of the water. The first meeting of lava and air. It is the birth of an island. The process is one of both gentle creation and dramatic transformation. As the hot, glowing lava, 1,000 degrees or more, touches the cool ocean water, it creates a spectacle of steam and sound. It is not always a violent explosion. Often, it is a sustained, powerful hiss, a great white plume of vapor rising into the sky. This cloud of steam is the first flag of the new land, a signal visible for miles that something new is emerging from the deep. The lava itself is transformed by the water. The rapid cooling shatters the molten rock into fragments of black, glassy sand, and jagged blocks of stone. This material, known as hydroclastic debris, builds up around the volcanic vent, forming a cone that rises from the waves. The island grows with each pulse of the eruption. A river of lava might flow down the side of the newly formed cone and pour into the sea, extending the coastline foot by foot. The sound is a constant sizzle and crackle. The sound of stone being born. Picture the scene at night. The new island is a silhouette against the stars, but its edges glow with a fierce red light where the lava meets the water. The steam clouds are illuminated from below, a luminous, shifting canopy above the dark sea. It is a vision of primal creation, a glimpse back to the early days of our planet when the first continents were forming. There is no life here yet, only the raw elements of rock, water, and fire, dancing together at the boundary of two worlds. Over time, if the volcanic activity continues, the island grows larger and more stable. The loose cone of ash and debris is eventually covered and protected by more durable lava flows. The volcano builds itself a solid foundation. Rain begins to fall on the new land, carving the first small streams and valleys into its barren slopes. The rock, fresh from the mantle, is rich in minerals. It is a fertile ground, waiting, and life is never far behind. The first colonists are carried by the three great travelers: the wind, the water, and the wings. The wind brings the microscopic spores of lichens and mosses, which are the first to cling to the bare rock, beginning the slow, patient work of creating soil. They release tiny amounts of acid that break down the stone, and as they die, their organic matter adds the first hint of nourishment to the barren ground. The ocean brings seeds and debris from distant lands. A coconut, buoyant and hardy, might wash ashore after a journey of thousands of miles. A tangled mat of seaweed might carry with it small insects or crabs. These ocean voyagers find a foothold on the new beaches, establishing the first coastal ecosystems. And then come the birds. A seabird, looking for a place to rest, might land on the new island, in its feathers or in its droppings. It carries seeds from the plants it has eaten on other shores. These seeds find their way into the nascent soil, and the first true plants begin to grow. Ferns, shrubs, and eventually, the first hardy trees. With the plants come the insects, and with the insects come the land birds. A complex ecosystem begins to weave itself together, a green tapestry spreading across the black volcanic rock. This process can take centuries, even millennia, but it is a story of incredible resilience and hope. From a single point of fire in the middle of a vast ocean, a new world can be born. The entire Hawaiian archipelago, the Galapagos Islands, Iceland, and countless other islands across the globe are all monuments to this process. They are volcanic children, born of fire and water. So, as you drift in your mind's eye above this newborn island, feel the quiet power of this creation. See the steam rising. Hear the gentle hiss of lava meeting the waves, and picture the first green shoots pushing up through the black sand. The volcano is not an end. It is a beginning. It is the Earth's way of reaching up from its molten heart to create new spaces for life to flourish. Every tropical island, with its lush forests, white beaches, and vibrant reefs, carries within it the memory of a fiery birth. It is a paradise built upon the cooled embers of a volcano's heart, a testament to the creative power that emerges when the deep fire of the world finally touches the sky and the sea. Part 9. The Cradles of Life, Hydrothermal Vents, and the Deep Ocean. Our journey now takes us back beneath the waves, deeper than sunlight can penetrate, to a realm of crushing pressure and eternal darkness. It is a world that we once believed to be utterly devoid of life. But here, in the deepest, darkest corners of our planet, volcanic activity creates oases of warmth and chemistry that may hold the very secret to the origin of life itself. These are the hydrothermal vents. Imagine yourself in a small, silent, submersible, descending through the black water of the deep ocean. The pressure outside is immense, enough to crush a car as if it were a tin can. The temperature is just above freezing. For miles, you have seen nothing but the slow, silent fall of marine snow, tiny particles of organic debris drifting down from the sunlit world far above. The landscape on the ocean floor is one of mud and rock, a cold, desolate desert. Then, in the distance, A strange shimmer appears in your lights. As you draw closer, you see it a towering, chimney-like structure rising from the sea floor, some as tall as a skyscraper. It is not made of rock in the traditional sense, but of minerals that have precipitated out of hot water, and from its peak, a thick, black cloud billows upward, like smoke from an underwater bonfire. These are the black smokers. They are the surface expression of a volcanic system hidden beneath the ocean floor. Here, cold seawater seeps down through cracks in the oceanic crust. As it gets closer to the magma chambers that lie beneath, the water is heated to extreme temperatures, sometimes over 400 degrees Celsius. Hot enough to melt lead, but the immense pressure of the deep ocean keeps it from boiling. This superheated water becomes a powerful solvent, dissolving minerals and chemicals from the surrounding rock. It becomes a rich chemical soup, full of sulfur, iron, zinc, and other elements. This hot, mineral-rich fluid is buoyant, and it rises back to the seafloor with tremendous force, shooting out of the vents in a turbulent plume. When this superheated fluid meets the near-freezing ocean water, the dissolved minerals instantly precipitate, crystallizing to form the chimney structures. The smoke is actually a cloud of fine mineral particles, giving the vents their name. It is a place of extreme chemistry and temperature gradients, and in this seemingly hostile environment, life thrives in astonishing abundance. The energy source here is not sunlight. It is the earth itself. The chemicals pouring out of the vents provide the fuel for a process called chemosynthesis. Specialized bacteria and archaea, some of the most ancient forms of life on Earth, harness the chemical energy in compounds like hydrogen sulfide, the same compound that gives rotten eggs their smell, to create organic matter. These microbes form the base of an entire ecosystem that is completely independent of the sun. They form thick, slimy mats that cover the rocks around the vents. And this bacterial life supports a strange and beautiful community of animals. Giant tube worms, some over 6 feet long, with bright red plumes that filter chemicals from the water, cluster in dense thickets. Ghostly white crabs scuttle across the chimneys, their eyes atrophied from a lifetime in darkness. Mussels and clams, their shells packed with chemosynthetic bacteria, grow in dense beds. It is a city of life, pulsing in the dark, powered by the volcanic breath of the planet. This discovery, made only in the late 1970 seconds, revolutionized our understanding of life. It proved that life did not need sunlight to exist. It only needed water, a source of energy, and the right chemical ingredients. And this has led many scientists to a profound hypothesis. Perhaps it was in environments just like this that life on Earth first began. Think of the early Earth. Its surface was bombarded by radiation and meteorite impacts, but the deep ocean would have been a protected, stable environment. The hydrothermal vents would have provided a constant source of heat, chemicals, and mineral surfaces that could have acted as catalysts for the first complex organic molecules to form. The tiny pores in the chimney walls could have served as natural test tubes, concentrating chemicals and allowing the first self-replicating structures, the precursors to cells, to emerge. These deep-sea volcanic vents may not just be oases of life today. They may have been the very cradle from which all life on Earth arose. This idea extends our search for life beyond our own planet. Moons in our outer solar system, like Jupiter's Europa and Saturn's Enceladus, are covered in ice, but are believed to have vast liquid water oceans beneath their frozen shells. These oceans are dark and cold, but they are likely heated from within by tidal forces, and their floors may be dotted with hydrothermal vents, just like on Earth. If life can thrive in the darkness of our own deep oceans, powered by volcanic energy, then perhaps it can thrive in the hidden oceans of these distant moons as well. The search for alien life is no longer just about looking for green planets orbiting sun-like stars. It is also about looking for the faint chemical signatures of volcanic activity in the dark, hidden seas of our own cosmic neighborhood. So, as you rest, let your mind sink into the silent, deep ocean. Picture the towering chimneys, the billowing clouds of black smoke, and the strange, beautiful creatures that call this world home. Feel the warmth radiating from the seafloor, a gentle pulse of geothermal energy in the cold darkness. This is the volcano in its most nurturing form, not as a builder of mountains, but as a keeper of a hidden fire. A fire that may have sparked the first stirrings of consciousness on our planet. It is a reminder that life can be found in the most unexpected of places, and that even in the deepest darkness, the heart of the earth provides a light of its own. Our journey has taken us deep into the heart of our own planet. But the story of volcanoes is not confined to Earth. The same forces of heat, pressure, and geology have sculpted worlds throughout our solar system. Let us now drift outward, into the quiet, cold expanse of space, and visit the volcanic echoes on our neighboring worlds. Each one tells a different story of a planet's life, its energy, and its slow, inevitable cooling. Our first stop is Mars, the red planet. Mars today is a cold, dry, and geologically quiet world, but its surface is a museum of a much more active past, and its star exhibit is Olympus Mons. Imagine a volcano so vast that if it were placed on Earth, it would cover the entire state of Arizona. It rises nearly 14 miles, 22 kilometers into the thin Martian sky, making it almost 3 times the height of Mount Everest. It is the largest volcano in the entire solar system. Olympus Mons is a shield volcano, like those in Hawaii, built by countless flows of fluid lava over an immense period of time. But why did it grow so large? The answer lies in what Mars lacks. Unlike Earth, Mars does not have active plate tectonics. On Earth, a volcanic hotspot will create a chain of islands as the plate moves over it. But on Mars, the crust stayed still. The hotspot remained in one place, and the volcano just kept growing, eruption after eruption, for hundreds of millions of years. It is a monument to stillness. Today, Olympus Mons is dormant, perhaps extinct. Its last eruption may have been millions of years ago. It stands now in the silent, thin atmosphere of Mars, a sleeping giant, its colossal slopes covered in a fine red dust. To stand at its base would be to see its peak disappear beyond the horizon. It is a quiet reminder of a time when Mars, like Earth, had a fiery, beating heart. Now let us journey further out, into the realm of the gas giants, to a place where volcanism takes on a form so strange it defies our earthly imagination. Let us visit Io, the innermost of Jupiter's 4 largest moons. Io is not a quiet, cratered world. It is the most volcanically active body in the solar system. Its surface is a constantly changing canvas of yellow, red, orange, and black, painted by the ceaseless eruption of sulfur and silicate lava. Io is caught in a gravitational tug-of-war between the immense pull of Jupiter and the rhythmic tugs of its neighboring moons, Europa and Ganymede. This constant squeezing and stretching, called tidal flexing, generates tremendous heat in Io's interior. This heat has to escape, and it does so through more than 400 active volcanoes. Plumes of sulfur dioxide gas erupt from its surface, shooting hundreds of miles into space, creating a thin, temporary atmosphere that freezes and falls back down like snow. Lava flows, some hundreds of miles long, resurface the moon so constantly that there are no impact craters to be seen. Io is a world of perpetual renewal, a place where the ground itself is never still. It is not a world of gentle creation, but one of fierce, vibrant, and chaotic energy. A beautiful, violent jewel in Jupiter's orbit. But not all outer solar system volcanism is hot. Let us drift now to the frigid, distant reaches of the solar system, to the moons of Saturn and Neptune. Here, the temperature is so low that water ice is as hard as rock, and rock itself is a deep frozen mineral. But even here, there is a form of volcanism. It is called cryovolcanism, or ice volcanism, on Saturn's moon Enceladus. We have seen it in action. Great plumes of water ice and vapor erupt from deep fissures in the moon's southern pole, spraying into space. These are not eruptions of molten rock, but of liquid water from a vast, hidden ocean beneath the moon's icy shell. The heat source is again tidal flexing, Saturn's gravity kneading the moon's interior. These geysers of ice are a stunning discovery, hinting at a warm, wet, and potentially habitable environment hidden beneath a frozen surface. And on Neptune's largest moon, Triton, the Voyager 2 spacecraft saw something similar. Dark plumes of nitrogen gas and dust rising from the moon's icy surface. Scientists believe that sunlight, even though it is faint this far out, can warm dark deposits beneath a translucent layer of nitrogen ice. This warming causes the nitrogen to turn to gas and build pressure, until it erupts in a great cold geyser. It is a form of volcanism, powered by the faintest touch of sunlight on a world where the average temperature is negative 235 degrees Celsius. Finally, let us visit Venus, Earth's sister planet. Venus is a world of volcanoes. Its surface is covered with thousands of them, more than any other planet in our solar system. Vast volcanic plains cover most of the planet, and massive shield volcanoes rise from the landscape. But are they active for a long time? Scientists thought Venus was geologically dead, but recent evidence suggests that may not be the case. Strange fluctuations in sulfur dioxide in the atmosphere and thermal hotspots seen on the surface hint that some volcanoes may have erupted in the very recent past, or may even be active today. Venus is a hothouse world, its surface crushed under an immense atmosphere and baked at temperatures hot enough to melt lead. If volcanoes are still erupting there, they are doing so in an environment utterly alien to our own, their lava glowing dimly beneath the thick, permanent cloud cover. It is a world of hidden fire, a place that reminds us that even planets that seem static may still hold a quiet, simmering energy deep within. From the sleeping giants of Mars to the fiery heart of Io, from the cold geysers of the outer moons to the hidden furnaces of Venus, volcanoes are a common thread in the story of our solar system. They are the voices of planetary interiors, expressing the heat, energy, and life cycle of a world. And as you rest, let your mind drift through this cosmic gallery of mountains, some of rock, some of ice, some sleeping, and some eternally awake. Each one is a reminder that our Earth is not alone in its fiery creativity. The impulse to build, to change, and to release what is held within is a universal story, written in fire and ice across the quiet canvas of space. We have journeyed to the highest peaks and the deepest ocean floors. But there is another class of volcano we must visit. They do not always form towering mountains. In fact, their most dramatic expressions often leave behind vast, empty basins. These are the supervolcanoes, the sleeping giants of our planet. The name itself may conjure images of world-altering catastrophe, but let us approach them not with fear, but with a sense of quiet awe for the immense, slow-breathing power they represent. A supervolcano is not defined by the size of its mountain, but by the scale of its eruption. A supereruption is an event of almost unimaginable magnitude, one that ejects over 1,000 cubic kilometers of material, enough to cover an entire continent in a layer of ash. These events are incredibly rare, happening perhaps only once every 100,000 years or so. But when they do, they can alter the global climate for years, even decades. But the story of a supervolcano is not the story of its eruption. It is the story of its long, deep, and quiet slumber. Let us travel to one of the most famous of these sleeping giants, Yellowstone. In the heart of North America, when you visit Yellowstone, you do not see a single massive volcanic cone. Instead, you see a vast, forested plateau, dotted with geysers, hot springs, and bubbling mud pots. The volcano is the landscape itself. Deep beneath the ground, a colossal magma chamber, miles wide and several miles thick, lies sleeping. It is not a seething cauldron on the brink of explosion. It is a vast, semi-solid body of rock and melt, a geological lung that breathes on a time scale of millennia. The ground above it gently rises and falls over decades by just a few inches, as magma shifts and pressure changes deep below. This is the slow, steady breath of the supervolcano. The geysers and hot springs are the visible signs of this immense heat engine. They are like the warm breath of the sleeping giant on a cold day. Groundwater seeps down into the crust, is heated by the proximity of the magma chamber, and then rises back to the surface, creating the spectacular hydrothermal features that Yellowstone is famous for. Old Faithful, with its rhythmic eruptions, is not a sign of impending doom. It is a sign of a stable, long-lived system, a release valve for the planet's internal heat. To walk among these steaming vents is to feel the warmth of the Earth's heart, brought close to the surface. It is a place of deep and calming energy. When a supervolcano does erupt, the event is so large that the magma chamber beneath it empties. The ground above, no longer supported, collapsed downward, forming a huge, basin-shaped depression. This feature is called a caldera, and it is in these calderas that we find some of the most serene and beautiful landscapes on Earth. Let your mind drift to Crater Lake in Oregon. The deep, impossibly blue water fills a caldera left behind by the eruption of Mount Mazama about 700 years ago. The eruption was one of the largest in North America's recent geological history. But what remains is not a scene of destruction. It is a place of profound tranquility. The lake is fed only by rain and snow, making its water some of the purest in the world. The steep walls of the caldera shelter the lake from the wind, leaving its surface often as smooth as glass, reflecting the sky in perfect detail. The island that rises from the lake Wizard Island is a small cinder cone, a tiny volcano that grew within the larger one, a whisper of fire in a cradle of water. To sit at the edge of Crater Lake is to be in the quiet heart of a once mighty volcano. The power has passed, and what is left is peace. Or travel in your mind to the Ngorongoro crater in Tanzania. This vast, unbroken caldera, formed by the collapse of a giant volcano millions of years ago, is now a self-contained world. Its floor, over 100 square miles, is a sanctuary for one of the densest concentrations of wildlife in Africa. Herds of wildebeest, zebras, and gazelles graze on the fertile grasslands, watered by streams that flow down the caldera walls. Lions and hyenas stalk the plains. Flamingos gather in the soda lake at its center. It is a natural amphitheater for life, a lost world, protected by the circular walls of a collapsed mountain. The volcano, in its final great act, did not create a wasteland. It created an arc. These places teach us to see supervolcanoes not as threats, but as part of a much longer cycle. They are expressions of the Earth's deepest and most powerful rhythms. Their eruptions are rare and transformative, but their legacy is often one of quiet beauty and renewed life. They represent a power that operates on a scale so vast and a timeline so long that it transcends our human concepts of danger. It is simply the planet, living and breathing. So, as you rest, do not think of Yellowstone as a ticking clock. Think of it as a warm heart, beating slowly beneath the earth. Feel the gentle rise and fall of the ground, the slow breath of the giant, and picture the serene beauty of the calderas left behind. The deep blue of Crater Lake, the green, teeming floor of Ngorongoro. These are the monuments that supervolcanoes leave. They are not scars of destruction. They are cradles of peace. Vast, circular embraces of stone that hold water, life, and a profound, enduring silence. The greatest powers are often the quietest in their repose. The story of a volcano does not end with the cooling of lava or the settling of ash. That is merely the end of one chapter. The next chapter, and perhaps the most beautiful, is the story of return. It is the quiet, patient, and miraculous story of how life reclaims a world of barren stone and transforms it, once again, into a world of green. Imagine a fresh lava flow, cooled into a vast field of black, jagged rock. It is a sterile world, sharp, empty, and silent. The sun beats down on its dark surface, making it shimmer with heat. There is no soil, no water, no sign of life. It seems like a place where nothing could ever grow. But life is patient, and its pioneers are small and incredibly resilient. The first to arrive are carried on the wind, microscopic spores of lichens and mosses, weighing almost nothing, drift across the landscape and settle in the tiny cracks and crevices of the new rock. For a lichen, a partnership between a fungus and an alga, this barren world is an opportunity. The fungus can anchor itself to the rock, and the alga can create food from sunlight. Together, they begin the slow, essential work of creating soil. The lichen releases a faint acid that ever so slowly breaks down the surface of the rock, releasing its minerals, and when the lichen dies, its tiny body adds the first precious specks of organic matter to the nascent soil. This process can take decades, even centuries. It is the quietest, slowest form of gardening imaginable. As a thin layer of soil begins to form, the next wave of colonists arrives. The wind brings the seeds of hardy pioneer plants. Ferns are often among the first. Their spores are light enough to travel for miles, and they can find a foothold in the smallest pockets of soil. A tiny fern unfurling its fronds against the stark black rock is a profound symbol of resilience. Its presence creates a tiny patch of shade and traps a little more moisture, making the spot just a little more hospitable for what comes next. Insects and spiders arrive, their journeys often just as remarkable. A tiny spider might be carried for miles on a strand of silk, a process called ballooning. It lands on the new rock and begins to spin a web. The first hunter in this new world, insects, blown off course by a storm, find themselves in a strange, new land. They feed on the emerging plants and on each other, weaving the first threads of a new food web. With more soil and more plants, the process accelerates. Birds, attracted by the insects and the promise of shelter, begin to visit. They leave behind droppings that are rich in nitrogen and contain the seeds of berries and fruits they have eaten elsewhere. These seeds sprout, and soon, the first shrubs and small trees begin to take root. Their roots push deeper into the cracks in the lava, breaking it apart further and creating more soil. Their fallen leaves add to the growing layer of humus on the ground. Each new species that arrives changes the environment, making it suitable for others. It is a slow, collaborative process of ecosystem building. The new land, once silent and black, now hums with the buzz of insects and the calls of birds. The stark landscape is softened by patches of green. The 1,980 eruption of Mount St. Helens in Washington provided a living laboratory for scientists to watch this process unfold. The blast devastated a huge area, leaving behind a gray, lifeless moonscape of ash and pumice. Scientists expected recovery to take centuries, but life returned with a speed that surprised everyone. Tiny pocket gophers, who had survived in their underground burrows, churned the ash, mixing it with the old soil beneath and bringing buried seeds to the surface. Fireweed, a beautiful purple flower, bloomed across the gray plains. Its light, fluffy seeds, perfectly adapted for colonizing disturbed land. Within a decade, young alder and pine trees were beginning to grow, and herds of elk were once again roaming the slopes. The recovery is far from complete, but it is a powerful testament to the persistence of life. This story of renewal is not just about resilience. It is about opportunity. The new volcanic soil, as we have learned, is incredibly rich in minerals. The plants that grow here are often strong and vibrant. The ecosystems that develop are full of life. The volcano, in its act of apparent destruction, has actually provided the raw materials for a richer, more diverse world to emerge. So, as you settle deeper into relaxation, picture this slow, green tide of life returning to a barren land. See the first patch of lichen, a splash of color on black rock. Imagine the first fern, a delicate spiral of green in a world of stone. Hear the first bird song in a forest that is just beginning to be born. The story of the volcano is not a story of endings. It is a story of perpetual new beginnings. It reminds us that no matter how desolate a landscape may seem, life holds the memory of green, and with patience, with time, and with the help of the wind, the water, and the wings, it will always, quietly, find its way back. The power of a volcano creates landscapes, forges islands, and enriches the soil, but in its fiery heart, It also practices a delicate and beautiful art form. It is an alchemist, transforming simple elements under immense heat and pressure into some of the most beautiful treasures of the earth, crystals and gemstones. Let us now explore this hidden artistry. The quiet, crystalline beauty born from fire, deep within the earth, in the rising columns of magma, or in the chambers where it rests. A slow and patient process of cooling begins. As the molten rock loses its heat, its atoms begin to arrange themselves into orderly, repeating patterns. This is the birth of a crystal. The final size and clarity of the crystal depend on the conditions of its birth. If the magma cools very slowly, over thousands of years, the atoms have time to find their perfect places, and large, beautiful crystals can form. If it cools quickly, the crystals will be small, or may not form at all. One of the most dramatic and beautiful creations of a volcano is obsidian. It is not a crystal, but a volcanic glass. It forms when silica-rich lava cools so rapidly that crystals do not have time to grow. Imagine a lava flow meeting a body of water or cold air. Its fiery energy instantly frozen in time. The result is a stone that is smooth, dark, and glassy, with a deep, liquid luster. When fractured, it breaks with what is called a conchoidal fracture, creating incredibly sharp edges. For early humans, obsidian was a precious gift from the volcano. It was the sharpest tool available, used to make knives, arrowheads, and scrapers. It was, in a sense, the steel of the Stone Age. To hold a piece of obsidian is to hold frozen fire, a moment of rapid transformation captured in a beautiful, dark mirror. But when the cooling is slower, true crystals have time to be born. Within the cooling magma, pockets of gas can form bubbles, creating cavities called vugs. Inside these hidden chambers, protected from the immense pressure of the surrounding rock, crystals can grow with perfect geometric form. Amethyst, the beautiful purple variety of quartz, often forms in this way inside volcanic rocks. Imagine a rough, unassuming volcanic rock that, when broken open, reveals a hidden grotto of sparkling purple crystals, a tiny cathedral of light hidden within the dark stone. Some gemstones are not just formed within the volcano, but are carried by it from deep within the earth. The beautiful green gemstone, peridot, is a variety of the mineral olivine. Olivine is common in the Earth's mantle, the layer beneath the crust. Most of it remains forever hidden from us. But sometimes, when magma rises from deep within the mantle, it can carry with it large crystals of olivine. As the lava erupts and cools on the surface, these green gems are trapped within the dark volcanic rock. In places like Hawaii, tiny grains of peridot can be found in the black sand beaches. The green sparkle, a beautiful contrast against the dark grains. These gems are travelers from a world we can never visit, brought to us as passengers on a river of fire. And then there is the most prized gemstone of all, the diamond. Diamonds are not formed in the magma of most volcanoes. They are formed under conditions of unimaginable pressure and heat. Over 90 miles, 150 kilometers deep within the mantle. They are the oldest things many of us will ever touch. Some having formed over 3 billion years ago, they would remain hidden forever. But for a very special and rare kind of volcanic eruption, Tesa eruptions, known as kimberlite eruptions, originate deep within the mantle. They are incredibly rapid and powerful, blasting upward through the crust at supersonic speeds. This rapid ascent is crucial. It acts like an elevator, carrying the diamonds from the deep mantle to the surface so quickly that they do not have time to transform back into graphite. The common form of carbon, the volcanic pipe that is left behind, a deep, carrot-shaped column of rock, is what miners search for. Every diamond that sparkles on a ring or in a necklace is a survivor of a fiery, high-speed journey from the heart of the earth. A beautiful stowaway delivered to us by one of the rarest and most violent of volcanic expressions. Volcanoes also create more humble, but no less beautiful materials. Pumice is a volcanic rock so full of gas bubbles that it is lighter than water. It can float. Sailors have reported vast rafts of pumice, stretching for miles across the ocean, the remnants of an undersea eruption. It is a stone that floats, a solid piece of the earth that has learned to ride the waves. And there are zeolites, a group of minerals with complex, porous structures that form when volcanic rocks and ash react with alkaline groundwater. These minerals have a unique ability to trap other molecules, making them incredibly useful as natural filters and purifiers. So, as you rest, picture the quiet, hidden world inside a cooling magma chamber. See the atoms slowing down, finding their partners, and linking together to form the perfect, intricate lattice of a crystal. Imagine a dark, rough rock that holds a secret world of purple light. See the green fire of a peridot crystal carried up from the mantle, and feel the immense age of a diamond, a tiny piece of the deep earth brought to the surface on a volcanic breath. The volcano is not just a force of sculpting, it is a jeweler, a master artisan. It works in silence and darkness, under immense pressure, and its creations are scattered across the world for us to find treasures of light and geometry. Born from the planet's fiery heart, our journey has shown us the fiery birth of volcanoes, their patient growth, and the life they bring to the world. But what happens when the fire fades? What becomes of a volcano when its heart grows cool and its voice falls silent? Let us now drift to the slopes of these silent mountains, the dormant and extinct volcanoes that dot our planet. They are no longer places of eruption, but they have become something else, keepers of memory and sanctuaries of peace. A volcano is considered dormant when it has not erupted in a long time, but has the potential to erupt again. It is sleeping, not dead. The magma chamber beneath it may be slowly cooling and solidifying, or it may simply be in a long pause between pulses of activity. These mountains exist in a state of profound stillness. Their slopes, once barren fields of ash and lava, are now often covered in lush, mature forests. Their craters, once filled with glowing lava, may now hold serene, turquoise lakes. Imagine yourself standing on the rim of a dormant volcano. The air is clear and cool. Below you, a deep, circular lake reflects the sky like a mirror. The walls of the crater are carpeted in green, with trees clinging to the steep slopes. It is a place of almost perfect tranquility. There is no hint of the immense power that created this basin. The fire is a distant memory, a story told only by the shape of the land. Places like Mount Pinatubo in the Philippines, which had a massive eruption in 1991, now hold a beautiful crater lake. The landscape, once a scene of great devastation, has been reclaimed by water and life. It is a testament to the healing power of time. Extinct volcanoes are those that are considered highly unlikely to ever erupt again. Their connection to a magma source has been severed. The plumbing system that once fed them from the deep earth has gone cold. These mountains have fully surrendered to the forces of erosion and life over millions of years. Wind and rain wear down their once sharp peaks, softening their profiles. Glaciers may carve deep valleys or cirques into their flanks. Rivers find new paths across their slopes. These ancient mountains become part of the ordinary landscape, their fiery origins almost forgotten. Castle Rock in Edinburgh, Scotland. The dramatic perch upon which Edinburgh Castle is built is the remnant of an ancient volcanic plug. The city is built around the bones of a volcano that was active over 300 million years ago. The jagged peaks of the Isle of Skye are the weathered remains of another great volcanic system. They are no longer mountains of fire, they are mountains of story. These silent volcanoes become havens for life. Their rich soils, the legacy of past eruptions. Support unique écosystèmes. Rare plants may grow only on their slopes, adapted to the specific mineral content of the soil. The varied terrain of craters, ridges, and valleys creates a mosaic of microclimates, allowing a wide diversity of species to thrive. For animals, the slopes of a dormant volcano can be a sanctuary, a place of shelter and abundance. These mountains are also storytellers of stone. Geologists can read their layers like the pages of a book. Each layer of lava or ash tells of a different eruption, a different moment in the planet's history. By studying the chemistry of these layers, scientists can learn about the climate of the past, the composition of the deep earth, and the long, slow evolution of the planet itself. The mountain holds its own history within its body, a record written in rock. And for humans, these silent mountains have always been places of spiritual significance. Their great height, their often symmetrical beauty, and their past power have made them objects of reverence and awe. They are places of pilgrimage, of quiet contemplation. To climb a dormant volcano is to walk up through time. As you ascend, you pass through different zones of life, from the dense forests at the base to the hardy alpine meadows near the summit. At the top, the world spreads out below you, and you are surrounded by a profound sense of peace. You are standing on a place of immense sleeping power, a giant at rest. So, as you let your mind settle into an even deeper state of calm, picture these silent mountains. See them not as dead, but as resting. See their slopes, once black and barren, now vibrant with the green of forests. Picture the clear, still water of a crater lake, a blue eye staring up at the sky. Feel the profound peace that settles over a place where a great energy has passed and given way to stillness. These dormant volcanoes are the elders of the landscape. They have lived their fiery youth and have now settled into a long, quiet, and graceful old age. They are reminders that all power eventually finds its way to peace, and that in stillness, a different, more enduring kind of beauty can be found. They are no longer a threat, but a shelter, no longer a voice of fire, but a whisper of stone. Our journey through the world of volcanoes is now drawing to a close. We have explored their quiet beginnings in the heart of the earth, witnessed their patient artistry, and felt the deep peace of their slumber. For our final chapter, let us turn to the most intimate story of all, the connection between volcanoes and humanity. For as long as we have walked this earth, we have lived in the shadow of these mountains, and they have shaped not only our lands, but our minds, our stories, and our souls. Since the dawn of human consciousness, volcanoes have been a source of profound awe and wonder. To our ancient ancestors, An erupting mountain was not a geological event. It was the act of a god. The fire from the earth was the breath of a deity. The rumble from the deep was its voice. And the lava was its powerful, creative hand. Civilizations around the world have woven volcanoes into their most sacred myths. In ancient Hawaii, the goddess Pele was said to make her home in the caldera of Kilauea. She was a creator and a destroyer, a passionate and powerful deity whose moods were reflected in the eruptions of the volcano. The flowing lava was her body. The fine strands of volcanic glass were her hair. To this day, offerings are still made to her, a sign of deep respect for the living power of the mountain. In ancient Rome, the god Vulcan, the blacksmith of the gods, was said to have his forge deep beneath the island of Volcano, from which we get the very word volcano. The smoke and fire that rose from the mountain were from his celestial workshop. As he forged the thunderbolts of Jupiter and the weapons of Mars, for the people of ancient Japan, Mount Fuji was and still is a sacred place, a gateway between heaven and earth. It is not a god of fire, but a spirit of peace, beauty, and immortality. For centuries, pilgrims have climbed its slopes, not in fear, but in reverence, seeking spiritual purification and a connection to the divine. These stories are more than just folklore. They are a reflection of a deep, intuitive understanding. Our ancestors recognized that these mountains were not just inert piles of rock. They were alive. They had a spirit, a power, a presence. They were worthy of respect. And in giving them names and stories, we created a relationship with them, a way to live alongside a power far greater than ourselves. But our connection to volcanoes is not just spiritual. It is also deeply practical. We have lived beside them because they have offered us gifts. The volcanic soils, as we have learned, are among the most fertile on Earth. Civilizations have thrived on the slopes of volcanoes, their agriculture sustained by the mineral-rich earth. The very prosperity of these communities was a direct legacy of the mountain's fiery past. They lived with the risk, because the reward was life itself. Volcanoes have also provided us with the materials to build our world. The Romans used volcanic ash to create a form of concrete so durable that structures like the Pantheon still stand today. 2,000 years later, the stones carved from hardened lava flows have been used to build homes, walls, and temples. The obsidian, the sharp volcanic glass, was one of our first and most important tools. The volcano was a quarry, a provider, a source of strength and ingenuity. And even today, in our modern world, we continue to draw energy from them. In places like Iceland and New Zealand, geothermal energy, the heat from the Earth's interior brought close to the surface by volcanic activity, provides clean, sustainable power for cities and homes. We are literally plugging our world into the warm heart of the volcano, turning its ancient heat into our modern light. To live near a volcano is to live with a constant, quiet reminder of the power and beauty of the natural world. It is to feel a connection to the deep, slow rhythms of geological time. It is to understand that the ground beneath our feet is not static, but is a living, breathing entity. People who live in the shadow of these mountains often have a deep sense of place, a profound connection to the land that sustains and defines them. And so, our human story is intertwined with the story of volcanoes. They have been our gods, our providers, our inspiration, and our homes. They have shaped our myths and built our cities. They have fed us and given us tools. They have taught us about the immense power of the planet, but also about its capacity for renewal and creation. As you finally let go and drift completely into sleep, hold this final thought. You, too, are connected to these mountains. The minerals in the food you eat may have come from volcanic soil. The water you drink may have been released as steam from an ancient eruption. The very air you breathe is part of an atmosphere created by their long, slow exhalation. The story of volcanoes is not a distant, geological tale. It is your story. It is the story of where our world came from. They are the ultimate symbols of transformation. They turn rock into liquid, and liquid back into rock. They turn destruction into fertility. They turn the hidden energy of the deep earth into new land, new life, and new beauty. And in their long periods of slumber, they teach us the most profound lesson of all, that even the greatest powers find their truest expression not in constant action, but in a deep and lasting peace. Good night. Hello there, and welcome to the Peaceful Sleep Channel. I'm so glad you found your way here, to this quiet space. Maybe you've had a long day, or perhaps you're the kind of person who likes to fall asleep to thoughts of nature's grandeur, of the ancient forces that have quietly shaped our world. Whatever the reason, tonight's journey is for you. There is nothing you need to do now. Just rest. Let your breathing slow. Let the thoughts in your mind soften, and allow your body to grow light, as if gravity itself has loosened its hold. Because tonight, we won't be drifting among the stars. We will be journeying deeper, into the very planet we call home. We will listen to its heartbeat, a powerful, slow rhythm made manifest in mountains that breathe fire and stone. Tonight, we will explore the most relaxing facts about volcanoes. You may be surprised to find that behind their fiery reputation is a story of creation, of patience, and of a deep geological beauty. We will not speak of destruction, but of rebirth, not of chaos, but of a profound order, a dance of rock and fire that has been unfolding for billions of years. And just before we begin, if these peaceful explorations help you unwind, or give you a quiet way to end your day, consider gently tapping the like button and subscribing. It helps other sleepy souls find their way here, too. Now, let's begin. Our story of volcanoes does not begin on the surface, with towering peaks or glowing rivers of lava. No, our story begins somewhere much deeper, a place of quiet and almost unimaginable stillness. It begins in the heart of the world. Imagine yourself drifting downward, sinking through the Earth's crust, past layers of sediment that hold the memory of millions of years. You move through cool, solid rock, and then the space around you begins to grow warm. The pressure builds, and the silence seems to grow thicker, heavier. You are approaching the planet's core, a place where no light can reach, and no sound can escape. The Earth's core is not a roaring furnace. Picture it instead as a silent sun, a solid sphere of iron and nickel, hotter than the surface of our actual sun. It glows, not with light we can see, but with a primal energy. This heat does not come from burning, but from the memory of the planet's formation over 4 billion years ago, and from the slow, almost eternal decay of radioactive elements. Each decaying atom of uranium or thorium is a whisper of time, a tiny beat that helps keep the heart of the Earth warm. It is a cosmic ember, wrapped in thousands of miles of rock, quietly radiating its warmth across the ages. Its existence is a steady, s'il présent, a vast yet gentle source of power that underlies every motion on this planet. The heat from this sphere of metal does not erupt, it seeps, gently and relentlessly, into the rock that surrounds it. Outside this solid heart is an ocean of liquid metal. The outer core, here, molten iron and nickel swirl in slow, endless currents, their movement, slower than the growth of a tree, generates the Earth's magnetic field, the invisible shield that protects us from the solar wind. Think of it, an ocean of liquid metal, churning in eternal darkness, weaving a protective shell for all life on the surface. A cocoon of energy spun from currents too slow to perceive. This is where the planet's power begins to stir. Not in a fury, but in a waltz of gravity and heat that has lasted for billions of years. Every swirl in this metallic ocean is a note in the symphony of geology, a movement that will shape continents and raise mountains millions of years from now. Surrounding the core is the Earth's mantle. This is a strange world, not quite solid, not quite liquid. It is a thick, hot, and dense layer of rock that flows and deforms under immense pressure. But do not imagine a rushing river. The flow here is impossibly slow. The rock of the mantle moves at a rate of only a few centimeters per year, slower than your fingernails grow. It is a glacier of rock, a motion almost frozen in time. Over millions of years, these slow convection currents carry heat from the core up toward the surface. Like water gently rolling in a pot set on the lowest possible flame, this process happens in absolute silence, under a pressure that would crush anything we know. It is the quiet engine of the planet, a vast, tireless machine where rock behaves like thick honey, and time is measured in geological epochs. Every small stir in the mantle is a seed of change for the surface, a quiet preparation for the birth of a volcano. It is here, in the upper mantle, where the pressure eases just slightly and the temperature remains extreme, that the magic of transformation begins. Rock, under these perfect conditions, can no longer hold its solid form. It does not melt suddenly. Instead, it begins to sweat, to soften. The minerals with the lowest melting points start to liquefy, like tiny beads of dew forming on a cool leaf. These drops of molten rock, called magma, are lighter than the surrounding rock. They slowly, gently, percolate through cracks and fissures, gathering together, forming silent reservoirs of magma, luminous pockets of liquid trapped deep within the Earth's crust. These magma chambers are the waiting rooms of volcanoes. They can sit there for thousands, even millions of years, like hibernating creatures. Inside, the magma gently swirls, crystals forming and remelting. It is a world of patience. The magma is in no hurry. It waits. It gathers energy, dissolves gases from the surrounding rock, and slowly builds pressure against the crust above. This is not a violent process. It is like the slow breath of a sleeping giant, each breath taking millennia. Each magma chamber is a second heart, beating impossibly slowly beneath the surface, nurturing the energy for an event in the distant future, when the pressure has built just enough, or when a new fracture opens in the crust. The magma begins its journey upward. This is not a violent assault. It is a silent migration. The magma weaves its way through the weakest points in the rock, following existing cracks, sometimes melting its own path. It might move only a few meters in a year. The journey from magma chamber to surface can take centuries. Along the way, it might pause, forming smaller chambers, resting for years before continuing. It is like a subterranean river of liquid light, finding its way through a dark labyrinth of stone. Its progress is marked only by the faintest tremors, seismic whispers that only the most sensitive instruments could ever hear. It is the deep hum of the planet, the rustle of rock shifting to make way for the slow rise of liquid fire. And so, before there is any mountain, before there is any smoke or lava, there is this long and quiet journey. A journey that begins with the leftover heat of creation, is fed by the decay of atoms in the core, is shaped by the glacial flows of the mantle, and is carried out by the patient ascent of magma through the dark crust. The volcano is not an event, it is the culmination of a process that is ancient, deep, and profoundly peaceful. It is the moment when the heart of the earth, after millions of years of waiting, finally reaches for the sky. Let your mind drift with this slow current of molten rock. Feel the deep warmth of the earth's core, not as a scorching heat, but as a steady, enduring embrace. Imagine the patience of the magma, waiting in the darkness through the ages. Before beginning its long journey, there is no hurry. Everything moves in geological time, a rhythm measured by the breath of epochs. And in this deep stillness, you can begin to feel a sense of peace, the peace of a planet that is alive, breathing, and quietly creating. From the deep, quiet chambers where magma waits, our journey now rises to the surface. But the first volcanoes we will meet are not the jagged, explosive peaks of legend. They are something far gentler. They are the silent architects of our world, the shield volcanoes. To understand them is to understand patience itself, written in stone across entire landscapes. Picture yourself now, not in a place of fire and danger, but floating in the warm, quiet air above the Pacific Ocean. Below you, the island of Hawaii rests in the deep blue water, a green jewel fringed with black sand. This island, and the entire chain it belongs to, was not built by collision or upheaval. It was breathed into existence, layer by patient layer, by the soft and steady work of shield volcanoes. These are the largest volcanoes on Earth, yet their presence is not one of threat, but of serene grandeur. Their slopes are not steep and menacing, but gentle and broad, rising from the sea with a slope so gradual you could walk for miles without feeling you are climbing a mountain at all. They are named for their shape, the broad, rounded shield of a sleeping giant, laid upon the ocean floor. The secret to their gentle nature lies in the magma that feeds them. The magma here is different from the thick, sticky magma that fuels explosive eruptions elsewhere. This magma is fluid, runny, and low in silica, the mineral that makes other lavas thick, like paste. Imagine warm honey instead of cold molasses. Because it is so fluid, gases can escape from it easily, not building up to a violent explosion, but releasing in a steady, quiet sigh. The eruptions here are rarely a cataclysm. They are an offering. Let your mind drift to the heart of one of these mountains. Mauna Loa Kiloe. Deep below, a plume of hot rock from the mantle, a steady pulse from the Earth's heart, provides a constant source of heat. The rock melts, and the liquid magma rises, gathering in chambers just beneath the surface. It waits, not with tension, but with a quiet readiness. When the time comes, it does not blast its way out. It wells up. It overflows. Often, the eruption begins not at the summit, but along the volcano's flanks, through long cracks in the earth called fissures. Imagine a line of light appearing on the dark mountain slope at dusk. It is not a violent crack, but a gentle parting, as if the land itself is opening a curtain. From this fissure, lava emerges, not in a torrent, but in a glowing curtain of fire. Fountains of molten rock may dance into the air, sometimes hundreds of feet high, but they are surprisingly quiet. A soft roar like a distant waterfall. They are not explosions of debris, but graceful arcs of liquid light, falling back to earth to feed the flows that will build the land. And the flows themselves are rivers of creation. Watch as a stream of this glowing liquid rock leaves the fissure. It moves with a slow, inexorable grace. The surface may cool into a dark, silvery skin, wrinkling and folding like silk as the molten river flows beneath it. This is the lava known as pahuho, a Hawaiian word that captures its smooth, rope-like texture. It advances not with speed, but with a quiet, unstoppable persistence. It may creep forward for weeks, even months, covering the old land in a new layer of black stone. It is not an act of destruction. It is an act of resurfacing. The lava flows around obstacles, feels depression, and finds the path of least resistance, sculpting the world as it moves. The air grows warm around it, shimmering with heat, and the night glows with its soft, orange light. It is the earth's own blood, warm and alive, flowing out to heal and build. Over thousands of years, these gentle flows build upon one another. Each eruption adds a new, thin layer to the mountain's flank. It is a process of infinite patience. A single flow might add only a few feet of height, but over 1,000,000 years, these layers accumulate to create mountains that are, when measured from their base on the ocean floor, the tallest in the world. Mauna Kea, though its peak is only 14,000 feet above sea level, rises over 33,000 feet from the seabed. A colossal structure built from nothing more than these quiet, patient overflows. These volcanoes are living proof that the grandest creations in nature are often not the product of a single, violent event, but of countless small, gentle acts repeated over an immense span of time. Where this new land meets the sea, another kind of quiet magic occurs. As the glowing river of lava, over 1,000 degrees Celsius, touches the cool ocean water, you might expect a violent explosion, but often, the meeting is a gentle hiss, a great cloud of steam rising into the sky like a soft exhalation. The lava cools rapidly, shattering into black sand and forming new coastlines. The island grows, foot by foot, acre by acre. It is the only place on Earth where land is being created so visibly, so steadily. You can stand on a cliff of old, weathered lava and watch the birth of new Earth unfolding below you. The steam that rises carries the scent of sulfur and salt, the smell of creation itself. It is the planet's own alchemy, turning fire into stone and stone into land. And life is never far behind. Within years, sometimes even months, the first seeds, carried by wind or birds, find purchase in the cracks of the new lava. Ferns unfurl their delicate fronds against the black rock. Small shrubs begin to grow, their roots seeking out pockets of moisture. The process is slow, but it is a testament to life's tenacity. The land that the volcano offers is stark and new, but it is also rich in minerals. It is a blank canvas, and life, in its quiet, persistent way, begins to paint it green. So, as you rest, let your thoughts settle on these gentle giants. Do not picture them as mountains of fire, but as architects of stone. Picture the slow, steady pulse of magma rising from deep within the earth. Picture the graceful curtains of fire, the quiet rivers of glowing rock, and the patient building of land, layer upon layer. These volcanoes are not symbols of chaos. They are symbols of growth. They are the calm, creative force of the planet made visible. A reminder that even from the hottest fire, the most serene and lasting beauty can be born. The shield volcano does not shout its power. It simply builds, quietly and endlessly, offering new ground for the world to grow upon. Now, let us leave the gentle, sprawling slopes of the shield volcanoes and drift across the world to a different kind of mountain. Let your mind travel to the shores of Japan, where the perfect, snow-capped cone of Mount Fuji rises from the landscape, or to the Cascade Range of North America, where Mount Rainier and Mount Hood stand like silent, watchful sentinels. These are the stratovolcanoes, the iconic, beautiful, and complex mountains that have captured the human imagination for millennia. If shield volcanoes are the patient builders, then stratovolcanoes are the master sculptors, crafting their forms with a different kind of artistry, one of layering, patience, and immense, quiet power. Unlike the fluid, honey-like lava of Hawaii, the magma that feeds these volcanoes is thicker, stickier, and rich in silica. Imagine not honey, but thick, cool peanut butter. Because it is so viscous, gases cannot escape easily. They remain trapped within the magma, like bubbles in a thick stew, building pressure slowly over centuries. This stored energy is what gives these volcanoes their potential for more dramatic expression. But their story is not one of constant eruption. Their story is one of long, deep slumber. For hunas, even thousands of years, a stratovolcano can sleep. Its slopes covered in forests, its peak capped with snow, giving no outward sign of the slow chemistry unfolding deep within. Picture yourself on the quiet, forested flank of one of these sleeping giants. The air is cool and still. Birds sing in the canopy. A gentle stream, fed by melting snow from the summit, whispers over moss-covered stones. The ground beneath your feet feels solid, ancient, and permanent. It is hard to imagine that this entire mountain was built by fire, but it was. Its entire existence is a monument to a cycle of eruption and repose, a rhythm of geology that moves on a time scale far beyond human perception. The creation of a stratovolcano is a work of careful layering. Imagine a potter at a wheel, slowly adding layers of clay to build a vessel. The volcano does the same, but its materials are fire and ash, and its timeline is measured in epochs. An eruption occurs, perhaps not a colossal explosion, but a series of smaller events. A flow of thick, slow-moving lava oozes down a flank, not traveling far before it cools and hardens into a dense layer of rock. Then, perhaps, the pressure shifts, and an eruption of ash follows. A great plume rises into the sky, and the fine, gray particles drift down, blanketing the mountain in a soft, new coat. This ash, over time, compacts into a rock called tuff. Then, the volcano falls silent again, for a century, or 5, or 1,000 years. It rests. Snow falls and melts. Glaciers may form, carving gentle valleys into its slopes. Forests grow, their roots binding the layers of ash and lava together. The mountain seems to have returned to the earth, a simple peak of rock and ice. But deep below, the magma chamber is slowly, silently refilling. Gases are once again dissolving into the molten rock, and the pressure is imperceptibly building. When the next eruption comes, it adds another layer, another flow of lava, another blanket of ash, and so it goes. Over hundreds of thousands of years, lava, ash, lava, ash. Each layer contributes to the mountain's shape, building it higher and steeper. The hardened lava flows act as a strong internal skeleton, while the softer ash layers fill in the form, creating the beautiful, symmetrical cone that we find so awe-inspiring. Mount Fuji's perfect symmetry is not an accident of nature. It is the result of countless individual eruptive events, each one contributing its small part to the final, magnificent form. It is a masterpiece of geological patience. Even the more powerful eruptions, when viewed through this long lens, and become part of a creative process. When a